Hey guys, what's up people? How are you guys doing? Mitro, how are you guys doing? Welcome to the session guys. I hope all of you guys are doing fantastically well, having a super awesome day, having fun at the same time, preparing for your exams as well. A very warm welcome. Let me just see, I'm not able to see your chats. Alright, all good now. Yes. Ki hal chal people, all good? Welcome. Hi. Welcome, guys. Welcome to the session. I hope all of you guys have an amazing evening, chilling, and I hope you had your coffee, tea, or milk, or whatever, green tea if you're health conscious and whatnot. But yes, I hope you have had your refreshments and you're feeling all energetic because today we are going to be doing the Sprintex session number 2. This is the last of the Sprintex of physics because we have done 3 sessions already. This is going to be the last one wherein we'll be solving some questions on magnetic effects of electric current. Now, just to give you guys a picture of what Sprintex series is. Sprintex is where we take a couple of questions, all right, about 10 to 15 questions, and what we do is that we would try to do the question in as little time as possible. It's a sprint, it's not a marathon, it's not a walk, right? It's a sprint. So we'll try to do it as fast as possible. At the same time, we'll also try to quickly go through the concepts related to that so that you get a clear picture of what kind of questions you can expect in your boards, and more importantly, gives you the power, the strength, the agility that you require to solve these questions. I speak like I spoke like an athlete over there. Yes, so anyways guys, a very warm welcome. So I'll just get started without wasting much more time of yours because every minute of yours is very valuable, and I know that at this point of time, you guys have your brains going all over the place regarding your examinations, right? So before we start people, we have some awesome, super amazing announcements for you guys that is going to be coming up tomorrow. So watch out the space of YouTube for that. Some super exciting stuff is in the pipelines for you guys. It's called as Vitopia. Basically, it's a Wave 2.0. You'll be getting some amazing new updates tomorrow. So make sure that you guys are here for that, 12 p.m. So it's not going to take much of your time, hardly 1 hour of your time. And 12 o'clock though, who studies, right? 12 o'clock is like the time where you chill out with your parents and stuff. So join the session, sit with your parents also. Look at this new version of Vedantu at Vitopia. Basically, it'll be coming up tomorrow, 31st of March at 12 p.m. right? Okay, so in the last session people, we had talked about we had solved a couple of questions from magnetic effects of electric current, session 1, where we did a lot of questions from the force on a current carrying conductor, that is Lorentz force and stuff like that, about your hand rules and whatnot. Today we'll be solving questions based on DC motor, electromagnetic induction, and your hand rules. So be ready for that. For sure, we'll have a lot of questions which would actually challenge your thoughts, your brain. So be ready for that, and make sure that you stay till the end, pay attention to each and every question, and try your best to solve it as fast as possible. So it's not just about getting the answer right, it's also about how fast you're answering, because again, at the end of the day, in your examination, that 1 hour, 2 hour will just pass off just like that. Right now, it's like this theory of relativity. It's basically that in 1 hour, 1 hour seems like a lot of time, but then in your exam hall, by the time you close your eyes and open it, 1 hour is done. So we'll try to do it as fast as possible and be as precise as possible, right? Okay, so before that guys, one more thing. In the last session, I'd asked you a small little homework. This was the question: when is the force experienced by a current carrying conductor placed in a magnetic field the largest? This was a homework question that I asked in the previous Sprintex. I hope you guys have seen that video already. If you haven't, check it out. It's right there. You'll see some mic icon, or just scroll down in the description. You'll find it out. All right. Okay. Tell me guys, what is the answer for this question? Quickly, all the genius and geniuses out there. Tell me what is the answer for this one. When is the force experienced by a current carrying conductor? Please, exactly. Arre, Mama Ji, amazing. Exactly. When it's kept perpendicular, guys. When the magnetic field and current is perpendicular to each other, that is when the force. Sorry. Oh, what was that? Just give me a second. Some sort of gart. I think I think someone's cooking. Oh my god, that's like. Alright, so as I was saying, when it's perpendicular to each other, that's when the force is going to be maximum. My god, that was awesome. Sorry, people. Okay, and now this is the Sprintex schedule. So physics is done. This will be the last session of Sprintex for physics, but biology is not yet done. Biology, you have heredity and evolution with Maria ma'am and our environment as well. With Shilpi ma'am, for chemistry, you have periodic classifications of elements 1 and 2 that is still left out. So I think that's also pretty much done. English, on the other hand, Shweta ma'am has a lot of work left. So you have a lot of other sessions coming up for Gopal sir, that is math. You'll have a lot of other sessions as well. And then we also have Ananya sir with a lot of sessions coming up for geography, history and civics, right? I'm really sorry, guys. I know. For some reason, no, I'm not able to. Yes, finally, I feel free. Okay, let's get started. All right. So here's what I've done, people. I've done a very simple job for you guys to make your lives a little easier. I divided the questions into 3 portions. You have the 2 markers, 3 markers, and 5 markers. 2 marks, simple question, straightforward. Jujubbi. You have to write 1 or 2 lines, and that's more than enough. 3 markers is going to be a little bit more harder. You have to explain a little. And 5 mark though, you have to write the entire Mahabharat in order to get those 5 marks. So let's start with the 2 mark question. The question is this. A horizontal power line carries current in east to west direction. What is the direction of the magnetic field due to the current in the power line at the point above and at the point below the power line? This is the question, right? Alright. And for some reason, all of a sudden I feel like coughing a lot. Just give me 1 second, guys. Let me just give me 1 second. Just give me 1 second. I just have to cough it out. Just give me a second. Oh my god. Okay, I feel so much better now. That was so awkward. And this is going to be on the internet forever. Me coughing, my face, my eyes at that time. Yes, internet, enjoy it. Okay, so here's the question, guys. Okay, so the question is very simple. You have a simple power line. This power line is carrying a current from east to west direction. Now, generally when you say east to west direction, east would be your right hand side, west is your left hand side. So the current is flowing from your right to your left. That's what east to west means. Now the question is, what is the direction of the magnetic field due to the current flowing through the conductor when you see from the top and when you see from the bottom? So this is where the marks are divided. So first mark, the first 1 or 2 marks, 1 mark would be going for this part where you'll be talking about what is the direction of the magnetic field when you see from the top, and the other part would be when you see the magnetic field from the bottom, what is the direction of the magnetic field like. So yes, tell me guys. Absolutely right. Yes, exactly. So here's what happens, guys. When you have current flowing from east to west direction, all you have to do is use your right and thumb rule. So according to right and thumb rule, all you have to do is take your right hand and envelop the conductor such a way that the thumb shows the direction of current. So current is going in this direction right now. So when you see from the top, current is going from south to north. South to north. Look at the fingers. Look at your nails. From south to north. So from the top, it will be from south to north. And when you see from the bottom, it's from north to south. So when you see from the bottom, it's from north to south. So this is east, west, north, south. That's how it's going to be, all right? So when you see the direction of current from the top, if you look at the nails, from south to north. If you talk from the bottom, on the other hand, when you see from the bottom, it's going to be from north to south. So this is how you answer that question. It might seem a little weird at first, but you get used to it when you start imagining stuff. When you actually visualize it, you'll understand it better, right? So if you look at it from the above, from the top of the power line, if you look at it, it's from south to north. From below the power line, it's going to be from north to south. All right. Okay. Second question. Once again, it's a 2-mark question. So 2 minutes time in your examination. But here we will try to do it in less than 1. The question is, name and state the rule used to determine the direction of magnetic field produced around a straight current carrying conductor. The fact is, guys, we have done the exact same question yesterday as well. Yesterday, whoever were there live, we had done the exact same question yesterday also in the Sprintex first session of this one. So I'm guessing that you already know this. Which rule is it, people? Anyone? I have a very bad memory. So can you help me out with that? What is this rule called? Exactly, Mamaji, exactly. This is nothing but Maxwell's right-hand thumb rule, or you can just write it as the right-hand thumb rule. This is the rule that is used to find out the direction of magnetic field if you have a straight current carrying conductor. Now, since this is one part of the question, so this will fetch you 1 mark. The other part of the marks that you get is basically from stating the rule. So if you have to state the rule, it just says that if you have a straight current carrying conductor, if you hold the conductor in your right hand such a way that the thumb shows the direction of current and the enveloping fingers that are there shows the direction of the magnetic field. So that's as simple as that. Thumb shows the direction of current and the enveloping fingers that are there shows the direction of the magnetic field. As simple as that. All right. So this is your right hand thumb rule. Very simple question. I'm pretty sure you already know this. I don't think I need to explain that any further than that. All right. Third question. Once again, 2 mark. 2 minutes time in your exam. We'll try to do it in less than 1. The question is, explain the meaning of the word electromagnetic and induction in the term electromagnetic induction. They've not asked you what is electromagnetic induction. They have asked you what is the meaning of the word electromagnetic and the word induction. What do you guys think? This is more of a English question than a physics question, but I'm guessing that you know what it means. Anyone who knows what electromagnetic means? Anyone out there who actually knows the meaning of the word electromagnetic induction? Anyone? They have not asked you to define electromagnetic induction. Bear in mind that they have not asked you to define it. All they have done is they have asked you to tell the meaning of the word electromagnetic and induction. Exactly, Mama Ji, amazing, no? Exactly, correct, valle, super awesome. See, electromagnetic means it's nothing but electromagnets or electromagnetism is nothing but when a magnetic field is created due to the passage of current. When current is flowing through a conductor, the magnetic field created around it, that is what is called as electromagnetism, all right? Induction, on the other hand, is nothing but, it's nothing but, creating something, or you can say induction is nothing but producing something. Or in this, if you talk about, in this particular scenario, you can say that there's a current induced or current produced in the conductor. So that is what induction means. Induction means basically there's something produced without being an actual contact. There is something produced in the conductor, or there is something being, there's something being created, or there's some change made in the conductor due to the passage of, or due to the movement of magnetic field. That is what is called as induction. Now again, to make it one step better, I would say please make sure that you explain electromagnetic induction also, what electromagnetic induction is, just so that they don't deduct your marks for all this, because I'm pretty sure majority of you guys, when it comes to explaining terminologies as such, we are all good at by-hearting stuff, by-hearting definitions, but when it comes to certain words, it's very difficult for us to explain in our own words. So just to be on the safer side, I would suggest you to define what is electromagnetic induction. It is nothing but when a moving magnetic field is linked to a conductor, there is a current induced in it. That is what is called as electromagnetic induction. All right, simple question, but again, it's a twisted way of asking the same question. All right, so here for some reason, please don't go with this. Electromagnetic means production of induced current. No, it's not. So please don't go by this. Just listen to what I just said and don't do what I just kept it on the, what you see. Listen to what I hear. So listen to what you hear. Don't listen to what you see. Don't follow what you see. All right. Okay. So that's the end of the 2 markers, guys. We have done 3 questions so far. Let's go on to the 3 markers now. So 2 more questions, as you guys notice. the questions are quite simple, but some of them are quite twisted. It's not always straightforward. So that is why reading your NCRT and being sure of the concept is very important, because when you're sure of the concept, it gets, no matter how the question is asked, you'll be able to answer it, because at the end of the day, it's the same question which is asked in a different manner. All right. So be sure to read your NCRT and be thorough with the concepts. Watch the videos, read your NCRT, practice questions so that you get a good knowledge of how to approach these kind of questions. Okay, let's go to the 3 markers. Enough talking. All right, 3 markers. First question, 3 minutes time in your exams. We'll try to do it in less than 2. The question is, state the rule to determine the direction of current induced in a coil due to the rotation in a magnetic field. So which rule would you use to find out the direction of the induced current in a coil? Very simple question, guys. Very simple question. Which is that? Induction stands for the action or process of bringing out, giving rays to something. Wah, Akshita ji, wah. All right. Exactly, guys. Sarah, no, it's exactly. It's Fleming's right-hand rule, guys. It's Fleming's right-hand rule. Fleming's right-hand rule is the one. Right-hand rule is the one that is used, or that you use to find out the direction of the induced current. Since it's a 3-mark question, you can't just write that and let it go. All right, you can't just write that and expect, sir, हम तो लिख लिए सब कुछ, अब तो हमें full mark मिलना चाहिए. No, nothing like that. All right, you have to make sure to define it as well, because a 3-mark question, I would say go one step ahead and define what is Fleming's right-hand rule. You guys know the drill. I'll just quickly go through it. So according to Fleming's right-hand rule, if you take your right hand and extend your thumb, index finger, middle finger such a way that they're all perpendicular to one another or each other, in that case, the index finger shows the direction of the magnetic field, the thumb shows the direction of the force on the conductor or the direction of motion of the conductor, and last but not the least, your middle finger shows the direction of the induced current. If you can draw it as well, and draw it and show it. All right, if you can draw this whole thing and show it. All right, but again, like I would say, don't do it because it takes a lot of time. So instead, you can just draw. You can just draw this layman diagram. That would be more than enough. You don't have to do the entire thing. Like don't basically draw the whole hand and sit and detail it, color your hand and all that. You don't have to do that. Sir, my hand does not look perfect. I have to draw fingernails. What is it called as fingerprints and all that. I have to don't do that. All right, because at the end of the day, it's not art and craft exam, it's physics exam. So don't spend too much time on it. Just draw a layman diagram. That's more than enough. All right, arrows are more than enough. All right, okay, let's go on to the next question. 5th question, again a 3-marker, 3 minutes time in your exams. We will try to do it in less than 2. The question is, what is an electromagnet? And what decides the polarity of an electromagnet, and list the 3 factors which affects the strength of an electromagnet. All right, so let's start with the first question. What is an electromagnet? How do you define an electromagnet? Very simple question. Very, very simple. The fact is, guys, you've been studying about magnetism ever since your 6th standard. Ever since your 6th grade, you've been studying about magnetism, electromagnets and everything. So I'm guessing that you already know this, but for all those who do not know how to define an electromagnet is nothing but a solenoid in which you have a soft iron core placed. A soft iron core placed in a solenoid, that is what is an electromagnet, because the solenoid itself behaves like a bar magnet, and when you introduce a soft iron core, the soft iron core also gets magnetized, thus making or creating something known as electromagnets. Now, how do you decide the polarity of electromagnets? Quite simple. What is that rule, people? Anyone who remembers that? What is that? Exactly, they are temporary magnet. They only behave like a magnet when current is flowing through it. The minute the current starts flowing through it, it stops behaving like a magnet. But yes, what decides the polarity? Exactly, guys, exactly. You have to always mention this part. It's nothing but the clock face rule, or you can say it is nothing but the direction of current. So what does it say? If current is going in clockwise direction, then that is the south pole, and if current is going in anti-clockwise direction, that is the north pole. So direction of current is what you require in order to find out the polarity of the magnet. So that would basically give you 2 marks. So far 2 marks you have achieved. To complete the third mark, you should also, to get the complete 3 marks, you need to answer the third question also, which is list the 3 factors on which the strength of electromagnet depends on. What are the 3 factors that it depends on? Quickly. Very simple question. Again, that is going to complete your 3 marks. Otherwise, you'll only end up getting 2 marks. So do not forget this also. Third part of the question is what factors does it depend on? Exactly. The current flowing through the conductor is the first factor. We know that the magnetic field around a conductor is directly proportional to the current. So more the current, or if you were to replace a low voltage battery with a higher voltage, that means there's more current flowing through it, which means that the magnetic field created around it would also be far more stronger, far more superior. All right, second factor that it depends on, exactly the number of turns, which is nothing but the length of the conductor. So length of the conductor is also a very important factor. One is the amount of current flowing through it. The second one is the length of the conductor. So these 2 factors are actually the ones that actually decides how strong of a magnetic field is created around a conductor. One is the amount of current, the other one is the length of the conductor, which is nothing but the number of turns. So if you have more number of turns, you would have a stronger magnetic field created around it. Alright, so these are the 2 factors that it depends on. Alright, so with that said, people, let's go on to the 6th question. Yeah, you can also mention the soft iron core as well. You can mention that also. Introducing a soft iron core, that is also a factor, right? If you were to introduce a soft iron core, that would create it more, make it much more stronger. You can mention that also. Alright, let's go on to the 6th question, guys. Again, 3 mark, 3 minutes time in your exams. We will try to do it in less than 2. This is actually a very straightforward question. Such an easy question this is. If you know the concept of electromagnetic induction, this shouldn't be a problem at all. This is very straightforward, very simple. The question is, a coil of insulated wire is connected to a galvanometer. Alright, what should be, or what would be seen if a bar magnet with its south pole moves towards one face of the coil? Alright, you have a simple insulated solenoid or a copper wire, insulated coil of a copper wire, which is nothing but a solenoid, and it's connected to a galvanometer. You have a bar magnet. The side that is facing the coil is the south pole. Now the first part of the question is, if you move this magnet quickly towards the solenoid, what would happen in this case? Exactly, there's a current induced in the coil, which means that the galvanometer will have a deflection because there's a current induced. There's a change in magnetic field, and if there's a change in magnetic field, there will be current induced. That's exactly what happens over here. Simple. Second question is, if you move the magnet again away from the coil this time, as quickly as you did before, what would happen this time? Exactly, again there's going to be a deflection again, but exactly, that is the key word there, people. There will be a deflection, there's no doubt about that, but the deflection will be in the opposite direction. Why? Because now the magnetic field is going away from the coil, so there's going to be a deflection, but the deflection is going to be in the opposite direction. So deflection in the opposite direction is what's going to happen. You can mention that. I know there's going to be a momentary deflection. Momentary means it's only going to last for a couple of seconds, and then again it's going to come back to zero. Okay. Third part of the question is, what if you take the magnet and place it at one of the face of the coil? Then what would happen? Exactly, guys, there'll be no deflection. Why no deflection? Because in order for current to be induced, you need a change in magnetic field. You need a changing or a moving magnetic field, and the minute you stop the magnet, there's going to be no change in magnetic field, and hence no current. Last question, what is this phenomena called as? Very simple. What is this phenomena called as? Exactly, electromagnetic induction or EMI. Simple. 3 marks, easy peasy. You can easily get these by just knowing the concept. Don't have to do anything else. All right. Okay. I hope it's clear so far. Let's go on to the seventh question, right? Seventh question is very simple, guys. Again, a very simple question. This is directly taken from your DC motor. The question is, explain the function of the parts of these electric motor. The first one is the armature coil, the second is the brushes, and third is the split ring. I don't want you guys to write the entire Mahabharata. I want you to explain in your own words what is the function of the armature. What is the function of it? Like, what does the armature coil do? Why do you even have it? Like, if it is not needed, why do you have it then? What is the need for it? What does it actually do? Come on, guys, come on. What does it do? Quickly. Exactly, guys, exactly. See, the thing is that, no, the armature coil is nothing but the conducting coil. And this conducting coil is placed between the magnetic field so that when current is flowing through the conducting coil or the armature coil, it will experience a force and start to rotate. Alright, you have to explain that in detail. Just don't just write, sir, it rotates. No, you have to mention that. Why does it rotate? Because it's placed between a magnetic field. And the minute current starts flowing through it, it will experience a force. And because of that force, it will start to rotate. So mention the whole thing. Alright, because so it's each of them is carrying 1 mark. So be sure to explain it in detail, in brief. Okay. Second, what is the function of the brushes? Like, what is the need for brushes? Why do you have carbon brushes in your motor to clean the motor or what? Getting it? Brush, carbon brush, getting it? Like vacuum cleaner. To exactly, Saraji, exactly. Carbon brush basically forms a connection. It basically connects the split ring to the external circuit, or you can just mention circuit. Alright, it is basically the one that connects. It's like a bridge which connects the split ring, the internal circuit to the external circuit. The internal circuit being the armature coil and the split ring, that is connected to the external circuit through the carbon brushes. Last but not the least, people, is the split ring. What is the function of your split rings? Why do you have split rings in DC motors? What is the reason for that? Like, is there any particular reason, or you just, because there's nothing else to fill up the gap, they just put it? What is the reason for it? Exactly, guys, exactly. Split ring is also known as the commutator because it is actually helping in changing the direction of current. Simple as that. Right? Again, guys, see, working of DC motor is a short question. Either they might ask you as a full-fledged 5-mark question, or they might ask you as a 3-mark question. They could even ask you as a 2-mark question just of a particular part. But for sure, you will have questions from DC motor. So I want all of you guys to be 100% clear with the concepts of this. I have already made several videos on this one, so make sure you check that out. You'll find it super duper easy. Once you watch that video, take 10 minutes of your time, read your chapter once, read your NCRT once. It'll be crystal clear. You'll never forget it after that. But you need to make sure that you do it, because it's a short question. When you know something is going to absolutely appear in your exams, why would you want to lose marks on it? Please don't. Alright, don't do that to yourself. You'll regret it later. Alright. Okay, let's go on to the 8th question, guys. Now this again is a very important one, because this type of questions can definitely come in your boards. Alright. It's a 3-mark question, 3 minutes time in your exams. Let's try to do it in less than 2. The question is, an alpha particle enters a uniform magnetic field at right angles to it as shown in the figure. Stating the relevant principle, explain in which direction will the alpha particle move. Now, see guys, it's a 3-mark question. There's 2 parts to this. There's 2 parts to it. First of all, you have to state which principle would you be using over here, or which principle is applicable in this case. That's the first part of the question. The second part of the question is, you have to figure out in what direction this alpha particle is going to deflect. Got it? Simple question. Okay, first part. Let's start with the first one. If you have an alpha particle, which is generally positively charged, alphas are generally positively charged particle, right? We have already studied that in chemistry. So alpha is positively charged. So this alpha particle, if it is passing through a magnetic field and if it's perpendicular to the magnetic field, what principle would be applicable over here? What is that principle? Right and thumb rule is the rule. What principle is this? Right and thumb rule. Right and thumb, you're going to use right and thumb rule over here. Day, sure, pakka. I'll log the answer. All right. Okay, what is the principle, people? What is the principle? Alright, I thought everyone would know this. The principle used over here is what? Is nothing but Lorentz force, people. Lorentz force. It's nothing but when a current carrying conductor is placed in a magnetic field, it will experience a force. That is the principle, isn't it? It's basically dependent on Lorentz force. So when a particle is passing through a conductor, when a particle is passing through through a magnetic field, it will experience a force. That is the principle that it depends on. So Lorentz force is the principle. Okay. Now, which rule would you use over here? If it's Lorentz force, you have to use what? Fleming's left-hand rule, where thumb shows the direction of force, index finger shows the direction of magnetic field, and your middle finger shows the direction of current. Again, guys, they are not talking about induced current here. They are talking about a particle, a simple positively charged alpha particle, which is passing through a magnetic field. When it's doing so, that particle will experience a force. That force is what is indicated by your Fleming's left hand rule, not right hand rule, but Fleming's left hand rule. Please make sure that you get that corrected. So Fleming's left hand rule is the one that we use. Last but not the least, in what direction is this alpha particle going to move? Pay attention, people. Your index finger shows the direction of the magnetic field. So magnetic field is going from your left to your right. So this is the direction of the magnetic field. Now the alpha particle, which is a positively charged particle, is going in the upward direction. So it's going in the upward direction. So your middle finger is pointing upwards. Your index finger is going in this direction. What is the direction of the force on the alpha particle? It will be into the page. It will be into the page. Basically, it's going to go in. You can say it's from south to north direction. South to north direction, or you can just mention into the page. All right, not out of the page, huh? Why would it be out of the page? Think about it. The particle which is shown by your middle finger is going in the upward direction. Your middle finger is pointing from east to west. Sorry, from west to east. So what is the direction of the force? It will be into the page. Got it? Again, you need to practice, people. Again, this is very easy to, very easily you'll end up losing marks on these kind of questions, because you might think that it's too easy and you can easily do it, but you end up making some silly mistakes like this and end up losing marks. So please avoid that. All right. So they've given the entire explanation. You can download the notes later and go through it whenever you get some time, right? So according to Fleming's left-hand rule, the direction of alpha particle is perpendicular. So it's basically going to be perpendicular. Obviously, it's going to be perpendicular. Basically, it'll be into the page. All right. So that is the answer for this question. All right. Moving on to the, see, that is the thing. Okay. Please remember this, people. We always take the direction of current. And when you talk about direction of current, it always goes from positive to negative only. No. Positive and negative, right? We don't, or positive terminal to negative terminal, right? We don't, if it is electron, if they've given the direction of electron, then you have to take the opposite direction. But if it's a positively charged particle, then you'll take that direction itself. That is the difference. All right. See, if it is an electron, if they had mentioned that it's an electron passing through a magnetic field, then the middle finger would have been in downward direction, because you will take the direction of current. Direction of the conventional current is opposite to the direction of electrons, right? So that will be in the downward direction. Since they're talking about an alpha particle which is positive, you will take the same direction itself. All right. Okay, with that said, guys, let's go on to the 5 markers now. Almost towards the end. I'm not going to bore you people too much and cook your brains a lot. Almost done. 5 markers, very, very important. You guys know that each and every mark count in your final exam. And this is by far the ones that is the most humongous, the hulkiest, the biggest, the Abhishek sirs of the question papers, which is basically big and massive and huge. And humongous and enormous 5-mark questions. All right, so let's go to the 5-mark question. Now, a 5-mark question in your examination, you would take about 4 minutes to do this, but we'll try to do it in less than 3. All right, at least 1 minute, though we have to banta hai. Here's the first one. Define electromagnetic induction. That you've already done it. Electromagnetic induction is what? When a moving magnetic field is linked to a conductor, there's a current induced in the conductor. That is what is electromagnetic induction. We've already explained this a billion times by now, so I'm just going to skip through the next one. Second part of the question is, two coils P and S are wound over the same iron core. Coil P is connected to the battery and key, and coil S is connected to the galvanometer. All right. Okay. So here is the thing, guys. Just listen carefully. So you have one iron core. All right. One straight iron core. On one side, you have this coil. All right. Which is basically connected to a battery. Now, this is a very important question, guys. So please listen up very carefully. This is super duper duper important. So there's one battery and there's a key as well. So I'll just introduce a key as well. All right. And another coil that you have is connected to a galvanometer, isn't it? Yeah, one is connected. So this is P and this is S. This is connected to a galvanometer. So galvanometer is generally represented by G. So this is the drawing. Draw a suitable diagram to this arrangement and write your observations. Now that would get you 2 marks. So far you've gotten 2 marks. All right. Now to answer the rest of it. If the current in coil P is started by closing the key, so if you turn on the switch, what would happen to coil S? Go ahead, guys. What would happen to coil S? The minute you turn on the switch, for the first one, that is P coil, what would happen? Will it create an impact on S or not? Absolutely yes. Yes, Sarah, exactly. There's going to be a momentary deflection in the galvanometer. Because why? Because this has its own magnetic field, and the minute you turn on, the magnetic field is suddenly increasing, and because of that sudden change in the magnetic field, there's going to be a deflection in the galvanometer of coil S. Okay, now if the current continues to flow in P, what would happen then? If the current continues to flow in coil P, which is the case right now, what would happen to the deflection? What would happen to the deflection? If the current is continuing to flow, what would happen to the deflection? I really want to know how many phases. Exactly, the deflection will come back to 0, or in other words, there will be no deflection. Why? Because in order for you to induce a current, there has to be a changing magnetic field. The magnetic field has to change. But the minute you turn it on and leave it on for some time, the magnetic field around P will become stable. It is not changing anymore. Neither is it increasing nor is it decreasing. So why would there be a current induced in S then? Nothing. There will be no deflection. So again, the deflection will come back to 0. Okay, third part of the question now. If you stop the current, what if you remove the plug key now? If you turn off the switch, what would happen to the deflection then? What would happen to S, coil S? What will happen? Think about it. The minute you turn off the switch, what would happen to coil S? Okay. Exactly, guys. Exactly. There's again going to be a deflection. Again, there's going to be a momentary deflection. But this time, this deflection will be in the opposite direction, because now the magnetic field is decreasing, and since again decrease or increase is a change, there's going to be a current induced, but this time the galvanometer needle will be pointing in the opposite direction. All right, last question, guys. Last question. That's it. Explain the reason for such observation. Why does all this happen? Electromagnetic induction. Explain about electromagnetic induction one more time. It happens because there's a sudden change in the, or initially when you turn on the switch, there's a sudden increase in the magnetic field, because of which there's a current induced in coil S. That's why there's a deflection. Again, when you turn it off, again the magnetic field is decreasing. Again, there's a change in the magnetic field. So once again, there's going to be a deflection, but this time in the opposite direction. So this is the reason why all of this happens, right? So that's it, guys. That's all. Exactly. Due to the change in the magnetic field. All right. The last question, guys, that's it. We have one last homework question, that's all. But this one, I'm not going to explain it at all because I've done it a billion times already. Explain the construction and working of an electric motor using a label diagram. Please do it. I told you this in every session of, magnetic effects of electric current. I have done this question in every single session so far. So I think you already know the answer. You know what I'm going to say. So I'm just going to let it go, but I'll just quickly go, rush through the basic. So while you're asked when you're asked, about this question as a 5-mark question, I would tell you to start with the explanation of a motor, like what is a motor. So motor is a device that converts electrical energy to mechanical energy. Write that first. Put some of the uses of this, like where all we use electromagnetic, motors. Then go with the working principle of it. Basically, it works on the principle that of Lorentz force. That is when a current carrying conductor is placed in a magnetic field, it will experience a force. That is a working principle. After that, I would say to draw the diagram, explain the diagram a little, like what are the different parts, draw the diagram, explain the parts, and then last but not the least, then and only then write down the working of it. That is the whole explanation of how it works, how is the direction of current, and what happens to the coil. I've done this a lot of times. I know it's a dope question, but it's been asked so many times, so I'm just going to skip through it, guys, because I'm bored of telling the same answers over and over again. So this is the diagram. You'll have this is the solution. You can download it later. So you can talk about the direction of current and how the armature coil is impacted when the current is flowing through it, and how the split ring changes its position while the armature coil rotates, and everything that goes with it. Alright, guys, so that's the end of today's session, but we're not done yet because I have a homework question for you guys. I'm sorry that I couldn't put out the homework rockers in today's session. Really sorry for that. I know that a lot of you guys have actually answered. I could see the comments. I'm really sorry I couldn't put it up because I had a lot of meetings today, so it's been a really packed day. Really sorry for that, but yes, do give this one. I'll make sure next session when I come, whatever the session is, I'll put up the homework rockers of the previous one and this one in the next one. All right, the question is, give one application of electromagnetic induction. Like, where do we use electromagnetic induction? Put it down in the comment section, not right now, not in the chat box, in the comment section, and who puts down the answer first, I'll be putting up their name in the next session. Whenever I come live, doesn't matter what session it is, I'll make sure that your name is going to be there. All right, I'll make you famous. All right, so yes, people, that's pretty much it. That is all for this Sprint series. I hope you found this helpful. How many of you guys found, okay, tell me this, how many of you guys watched all the Sprint sessions so far, all the Sprint of physics and all the other subjects so far? Yeah, anyone here who's watched all the sessions? I've done 4 Sprint sessions so far. I'm hoping that you've already watched it. How many of you guys have watched it? Yeah, all right, thank you. So I hope that it was helpful, guys. I'm really hopeful that it was helpful for you guys, and you've found the questions challenging enough, and also helpful to with your preparations for your boards. I'm guessing that was the case. But yes, if you need anything more from our side, please do not hesitate. Always reach out to me. This is my Instagram handle. It's Anoop_Vedantu. I'll be posting up new updates over there whenever whatever time I get. And also, if you want to reach out to me, drop a mail. It's anup.manoharan@vedantu.com. All right, vedantu.com. That's my name. It's Manoharan, MANOHARAN. Unfortunately, there's no space to write there. That's why. So you can just take it down if you want to send a mail. Please do, and let me know if you have any doubts, and I'll try to clear it up. All right. So that's it, people. Hi, Pratyay. What's up? All right, guys. So that's all for today. Do not forget to like, share, subscribe, and spread the word to your friends. Send the video link to them as well, so that they can also find it helpful. So that they'll also thank you in their dreams and in their duas and all that. They'll also pray for you. All right, for your health and so that you also score well. Don't you want that? The more prayers, the better marks. All you have to do is share the video. Getting it? This is like that forward message that you get. No, if you don't forward it to 10 people and you have bad luck, it's exactly like that. Don't fall for it. I'm telling you. All right? Don't get bad luck. So forward this video to 10 people and you get good luck. Understanding? समझ रहे हो? Smart marketing tricks. I know. Alright, so I don't know how I became a teacher though. Alright, so anyways, guys, I'll catch you guys later. Take care of yourselves and have a fantastic evening. Stay safe. All the best for your exams, and follow me on Insta and drop a mail so we can connect with each other. Alright, peace out. Take care. Stay safe. Bye guys. Take care. See you all. Adios, amigos.